We're now going to look at some amazing examples of cognitive capabilities in non-human animals. We're going to start out by revisiting dog brain scans.
The dog project was hatched almost a year ago, and really the idea is to use brain imaging to figure out what dogs are really thinking. So there's all sorts of theories about my dog loves me, my dog thinks this, but how can we really know because they can't talk to us? So the inspiration for the project was literally on the mission that hunted down Osama bin Laden, and it was revealed pretty much a few days after that there was a dog on the SEAL team that did that mission. Turns out, there's obviously a lot of dogs in the military, and they're trained to do all sorts of tasks, the main task being scent detection for explosives and narcotics, and as well as patrol duty. I realized if dogs can be trained to jump out of airplanes and helicopters, we could certainly train them to go into an MRI so we could see what they're thinking. So the task itself is quite complicated because Callie has to walk up some steps to go onto the patient table in the MRI, go in the MRI, shimmy down and stick her head in what we call a head coil, and then hold still.
Still. Hey, that's better.
We're going to brain. Look at that. There are several brains there. Now that is, I'm impressed.
That is awesome. He's going to be so excited.
Yay! You're so good. We're so proud of you.
So when we saw those first images, it was unlike anything else. Nobody, as far as I know, had ever captured images of a dog's brain that wasn't sedated. This was a fully awake, unrestrained dog, and here we had a picture for the first time ever of her brain. And it was incredible. If we can actually capture brain images and see what parts of the brain are activating when we give hand signals, or when we talk to it, or when we point this way or that way, now we can really begin to understand what a dog is thinking. We hope this opens a whole new door into canine cognition, social cognition of other species, and really opening and really paving the way for understanding interspecies communication. And we think the dogs are the best for this. We have a mock-up of a scanner at home in our living room, and so she knows when I say you want to do some training, she goes and hops right up in the simulator and waits for her treats. Any dog person wants to know what their dog is thinking. But to the skeptics out there and the cat people, I would say, looking at the dog-human relationship is unique. There are no other animals like dogs. They are the first domesticated species, and as such, it really is like anthropology. Like we're almost looking at fossils, because the dog's brain represents something very special about humans and animals, how they came together thousands of years ago, and it's possible even that dogs have affected human evolution, that the people who took dogs into their homes and their villages may have had certain advantages, and there could be traits in those ancestors of ours, such as the ability to communicate with animals, social qualities that make them better mates and better people. So the reason to care is that, as much as we made dogs, I think dogs probably made some part of us too.
Dogs are amazing, and we've already seen many examples of that. Well, maybe not many, but we've seen some examples of that in previous segments. This whole area of animal cognition sort of got a lot of attention when Donald Griffin published this book, The Question of Animal Awareness, in 1976. And he followed it up with two other books, one in 1984 called Animal Thinking, and in 92, Animal Minds. And then other people started writing books along the same lines. Basically, the premise, as I sort of understand it in reading Griffin's books and some of the others, is that cognition is kind of like based on the kind of clever things that animals do. And this is something that I discussed in a previous segment. And, it's, to me, I kind of take it as a given, I guess, is one way of saying it. Of course they're cognitive. How could they not be cognitive? Animals are not little robotic wind-up toys. They have to be thinking and figuring out what it is they're doing. So I'm not quite sure why it got almost like its own subfield within animal behavior. People suddenly got fascinated by this. Yet the data were around for a long, long time in some cases. Now I'm going to be showing some more recent data, but again, it attests to the remarkable capabilities that animals can do. And we're going to be looking at some insects just to drive this point home. Starting with the assassin bug. So, here we have a termite nest. Assassin bugs like to eat termites. They have a special gland that enables them to grab bits off of the nest and basically glue these bits to its body to camouflage itself. And then it waits at the entrance, same as the exit, to the nest. And if you don't see it, there is our assassin bug right there. You can see its antennae. There's termites there. And it waits for a termite to emerge and it grabs it. And it basically sucks out the insides of this chitinous shell that make up the termite. Now, termites like to keep the nest clean. So when they detect that there is a dangling chitinous shell from the assassin bug at the entrance, another termite will come up and grab it, but in doing that, the assassin bug grabs that termite. It's almost like the assassin bug is going fishing.
Termites live inside a castle. They don't often leave the safety of their fortress. If they do, it's to build extensions or make repairs, and they're guarded by an army of soldier termites. With all this security, termites should be safe from attack. But waiting outside is their worst nightmare, an assassin bug in full disguise. Termites take a big risk when they open their fortress. They're blind, and the assassin has covered itself in their building material. To them, it's just another part of the nest. The termites simply blunder into it. The assassin bug sucks the termite's body dry. The workers try to close the gaps in their defenses as quickly as they can. They're still not safe until every tiny crack is sealed. In the meantime, the bug has a sinister use for its victim. Termites live by rules. They're fanatically tidy. A dead termite has to be taken to the communal graveyard, and the assassin bug exploits this obsession. All that the worker detects is a corpse, and the assassin bug shakes the body, teasing the worker. Compulsive tidiness will cost this termite its life. As if fishing through a hole, the assassin dangles the corpse as bait. Then it drops it and grabs the worker, the next in a chain of up to 20 serial murders.
So we can equate it with fishing, but really we're just looking at species-typical feeding behavior by the assassin bug that also capitalizes on species-typical nest cleaning by the termites. By the way, I don't think I would have used the word murder to describe what's going on here. The assassin bug is doing what assassin bugs do, what we all do when we're hungry, and that is get food and eat it. Grass-cutting ants. These are intriguing animals. And again, I want to intentionally use an insect example here just to show you the capabilities, the cognitive capabilities of non-human organisms.
The heads of these big-jawed individuals are not full of brain, but brawn. They give the species its name. They are grass cutters. They work all day, every day. The smaller ants down on the ground are porters with the job of carrying the grass segments back to the colony. Columns of them carry the grass back to the nest along highways as straight as Roman roads. Different members of the colony specialize in particular tasks in much the same way as people do. A single colony harvests 1/2 ton of grass a year, more than any other animal on these plains. But since they themselves can't eat it, why do they do so? The answer lies underground. They have one of the most extraordinary survival strategies in the insect world. The ants have dug a network of tunnels that extend downwards for over 7 meters. At the heart of the colony lies the key to their survival, a fungus. But this isn't sloppy housekeeping. This is a fungus that is found nowhere else on Earth. And the ants cultivate it assiduously. The big-jawed ants chop up the grass, covering it with an antibiotic saliva that kills every kind of fungus except this one. The ants are farmers. They feed the grass to the fungus, and the fungus thrives. The ants cultivate dozens of these fungus gardens throughout the colony. This is what they eat. The system is so efficient that a single colony can have 5 million members. But the fungus is also dangerous. As it grows, it releases carbon dioxide that could asphyxiate the entire colony. The ants' way of dealing with this danger is ingenious. They construct their nest so that it has an automatic air conditioning system. The outer surface is so shaped that the slightest breeze sucks out stale air through these central vents. At the same time, fresh air is drawn down through the outer vents, right into the heart of the nest. Our own societies have existed for thousands of years, but insect societies have lasted for millions.
So that's pretty amazing. I mean, they eat the fungus, but then the fungus that's building up causes some problems within the nest, and so they build their nest to ventilate the nest, and problem is solved. This is an archer fish. It's shooting water from the surface of the water at a bug. This, of course, is slow motion. It's going to hit the bug is going to fall into the water, and the archer fish will eat the bug. And we'll see it a little bit better here. Again, this is slow motion. Now, what's amazing is they do this with an incredible degree of accuracy. There's the bug, and the bug is history. And it's not a hit or miss thing. Again, they are very accurate. Moreover, they're capable of controlling that stream of water depending on how far away the vegetation is on which the bug is sitting.
The pitiful beetle is the target of a marksman that stalks the tropics of Asia and Australia. The archer fish. One of the few aquatic predators that can hunt prey outside its element. On average, it grows more than 6 inches long. But it can hit a target over 5 feet away, from tiny bugs to small lizards. It forms a tube with its tongue, then squeezes its gill covers to fire. A jet of water shoots out along the roof of its mouth. By positioning itself directly under its prey, it minimizes the effect of refraction of the water. Anyone who has ever tried to spear a fish knows the surface refracts your aim. But not the archer fish's aim. It can even gauge the weight of the target to calculate how much water to fire. A shot typically packs 10 times the force a bug uses to hold on.
When you think about it, it's about the same kind of a task that a pitcher in baseball would be faced with in terms of the velocity of the pitch, depending on the type of pitch, as well as the accuracy of the throw. That's pretty amazing. The dung beetle, another insect. So they eat dung, cow dung. And they also get moisture from the dung, so basically that's their source of food and water. These guys are found in desert-type climates. And they even will lay their eggs inside the dung. You can see a developing larvae in the larger photo inside the dung. So they treasure dung. They need dung a lot. And they will take dung with them once they find some, wherever they go, and they roll it along just like this. But sometimes bad things can happen. And now we're going to watch this dung beetle solve the problem. It's going to try various maneuvers to try to unspear the ball of dung. That makes sense. I think, that's something that a human would try to get underneath of it, see if that works. Unfortunately, the beetle seems to be unaware that it's speared at an angle, so just lifting upwards isn't quite going to work, at least not from that angle, even though it's going to try. I mean, it makes a little bit of progress, but not enough. The dung weighs a little bit too much than the beetle is able to deal with, so it goes around the other side, which makes a great deal of sense. And from the other side, it's now pushing upward to free the dung. There we go, and now it will go off on its merry way with its dung ball. Let's look at a bird, and it's a bird that you've seen before. The bird is probably in some ways smarter than this monkey in this cartoon, because this parrot not only says apple, but the kind of apple. The parrot, of course, is Alex. We saw Irene Pepperberg and Alex in a previous segment. I just want to show a few short clips, again, illustrating the African gray parrot's amazing cognitive capabilities.
Alex not only imitates the sounds of human words, amazingly, he can use them to describe aspects of his environment.
What is it?
Yes, that's right. What is it?
Wheat.
Yeah, shredded wheat. Good birdie.
Rock.
Yes, that's your rock.
Water.
Good parrot.
Watch now as Alex answers some rather difficult questions for a bird.
Come on, how many key?
2.
Good parrot. Oh, you wanted the wood instead? Okay. What's different?
Color.
Good parrot, different color. Think, what's same?
Shape.
That's right, same shape. How many?
2.
Good bird, that's right. What's same?
None.
None, good birdie, none same. Color different, matter different, shape different, none same. Good boy.
So you can see that Alex is really figuring these things out. You try to fool Alex, and you can't.
Hey, look, can you tell me, on the tray, how many green block? How many green block? Look on the
This
tray,
is a
how many
miniature logic
green
problem.
block?
Alex can't just count up all the green things, and he can't just count up all the blocks. Alex has never been trained with this particular collection of things.
How many green blocks?
2.
Good parrot, 2 green block, 2. Good parrot.
I want corn. Soft corn.
Soft corn, good parrot. We've got rock corn, that's dried corn, and we've got soft corn too.
Coal.
It's cold, yes, it's cold. It's from the refrigerator.
Go pick up corn.
Well, no, I'm not going to pick up the corn you threw down.
I love birds that have a sense of humor. Unfortunately, Alex died rather suddenly, totally unexpected. And I know Irene Pepperberg, she was with him like the night before. She went home, got a call from the animal caretaker in the middle of the night. Alex was dead in his cage. A necropsy indicated it looked like it was either a heart attack or a stroke. Not 100% sure which. But nonetheless, her work has continued with other African gray parrots. And now some primate examples. Tool use. Okay, tool use is a good example of animals' cognitive capabilities. This, of course, is slow motion for dramatic effect. Blame the BBC, I didn't do it. And that's a capuchin monkey. And the thing about capuchin monkeys, when they do this, they kind of hit whatever it is they're targeting with about the same level of force. So they don't make an adjustment for that. But nonetheless, they're able to crack open most of the nuts that they're trying to crack open. But now look at what a chimpanzee does.
The most impressive skill of all, which involves nimble fingers, hand-eye coordination, and intelligence, is nut cracking. Chimpanzees have gone a stage further than capuchins. They have learned how to carefully position the nut on an anvil and to judge how much force to use in order to crack the shell but not smash the kernel to pieces. Their use of tools is both efficient and precise.
Pretty remarkable. We're going to revisit the New Caledonian crow. Again, talk about amazing capabilities. This has to be the most intelligent bird on Earth, if not as a species, not this particular individual. Maybe even better than some primates.
Alex studies wild birds, which he releases after 3 months of research. This one is nicknamed 007, and it's about to attempt what Alex believes is one of the most complex tests of the animal mind ever constructed. The bird is familiar with the individual objects, but this is the first time he's seen them arranged like this. 8 separate stages that must be completed in a specific order if the puzzle is to be solved. And if the bird succeeds, it'll be a world first. He takes time to have a look and then starts with the short stick. Stage 1. He finds it's too short to reach the food. He then sets off to get the first stone. But he drops it. And another. He seems to be stuck. But then, something seems to click. He deploys the first stone. And then another. Got it. The 8th and final stage. Success. 8 individual stages of one complex puzzle completed.
That's the first time this bird was put in this situation, and you can see that it solved the problem perfectly. It seems like it deserves more than that little piece of food as a reward. Okay, who's better, humans or chimps? Well, it turns out that it's chimps.
Japanese researchers pitted young chimps against human adults in tests of short-term memory, and overall, the chimps won. Researchers at Kyoto University say that finding challenges the belief that humans are superior to chimpanzees in all cognitive functions. One memory test included 3 5-year-old chimps who'd been taught the order of Arabic numerals 1 through 9, and 9 human volunteers. They saw 9 numbers displayed on a computer screen. When they touched the first number, the other 8 turned into white squares. The test was to touch all these squares in the order of the numbers that used to be there. Results showed that the chimps could do this faster. Even after 6 months of training, the human students failed to catch up to the chimps.
That's pretty amazing. So we lose on that task relative to chimps. And the same in terms of this computerized maze.
So just how good are chimpanzees at planning?
One of our chimpanzees, Pansy, is essentially a genius at this. Not only is she excellent in running very complex multiple choice mazes that she's never seen before, but she can do it better than humans in many instances.
Tell me what you want. This is a remarkable finding. Not only does Pansy take very few wrong turns, but she can sometimes see the solution to the maze faster than a human.
To be able to look ahead and to find that clear way between where she starts and where she ends reflects a very active prefrontal lobe system. She's a genius.
But is she as good as the New Caledonian crow? Well, I guess we won't know. Anyway, those are some, what I think are pretty good examples of the cognitive capabilities of a very wide range of non-human animals.